So a matrix is an array of numbers. Now, one of the first things we're going to look at is an augmented matrix. This is what we use typically to solve, okay, is we're using an augmented matrix. An augmented matrix form, it represents a system of equations. I'm sure you remember how awful it was in Algebra 1 and Algebra 2, especially Algebra 2, where you had to do 3 equations with 3 unknowns, 2 equations with 2 unknowns, you know, the x, y. Turns out there's an easy technology way to solve all those, and has been since you've been in school. And we're just now teaching you how to do it. So, represents a system of equations, because you're not always going to have technology with you. So, for this guy right here, 2x plus 3y equals 6 and 4x minus 5y equals 8, we make it a matrix. Remember, a matrix is the big square brackets? We simply peel off the coefficients. Everybody knows what the coefficients are, right? So for 2, 3, 6, we just put down 2, 3. We're going to put a dashed line here and put 6 over here. So what's the next line going to look like? Good. 4, -5, and then over here?
8.
Okay. Now, we can put this in our calculator. If you look at your calculator, how do we put a matrix in our calculator? Okay, so let's get back to this. You've got it in your calculator. Now, reduced row echelon form uses what you've used last year. You used row operations. It uses row operations. You remember how you had to multiply a row and add it to another row and replace last year when you did matrix operations? Row operations to solve a system. Now, for a system of 2 equations and 2 unknowns, you will end up with a matrix that looks like this. 1, 0, and then some number that represents the solution for x. 0, 1, and some number that represents the solution for y. These will be numbers that represent the solutions. Now, that's for a 2 by 2. For a 3 by 3, 1, 0, 0, 0, 1, 0, and 0, 0, 1. I want you to notice that the x gets the 1 place, and in our equation, the x was the first variable, wasn't it? For y, it's the 2nd place, and for z, it's the 3rd place. Think alphabetical order. X, Y, Z, and notice that all the other places are zeros. So when we have a 1 in the x place and zeros, a 1 in the y place and zeros, and a 1 in the z place and zeros, then we have the solutions. Normally, last year, you had to do all kinds of matrix operations, and it was a pain. However, watch how easy it is with your calculator. Is everybody ready? We're going to solve that matrix. So here we go. If you look, I put it in there for you. You've got the matrix in there, don't you? So what you're going to do is you're going to go to matrix math.
Have you got Sly's number?
Yes, I do.
Will you text her and tell her her food is in the fridge?
I will. Josie's sick. I'll tell her.
Well, tell her she needs me to run it somewhere I can meet up with her or something.
All right.
Drop it by her house if she needs far. I don't know. Whatever she wants. I don't care.
All right.
Ain't got nothing else to do.
Must be nice.
Yeah, you got some of my formers.
Uh-huh. All right. So, going in, here we go. We know, guys, is that x equals, if you look, this is x, and this is your y. So my solutions, x is 27 over 11 and y is equal to 4 over 11. So my solution set, because it is a coordinate pair, isn't it, is 27 over 11, comma, 4 over 11. Everybody good? Now, we still have to account for no solution and infinitely many solutions, don't we? So no solution is there's zeros in the coefficient part. But a number for the solution. That would look something like this. 1, 0, 2, 0, 0, 1. This part right here is the part that tells us that it's no solution. So you see what I'm saying? There are zeros in the coefficient part, that's the first block, and then a number, like a 1 or a 12, it doesn't matter what number's there. That's where we know there's no solution, because 0 can never equal 1, can it? Now, what if there's infinitely many solutions? One row is all zeros. Okay? And that would look like this. Oops, hold on. Getting crazy with this. So this is the row that would tell us that they're infinitely many. Okay? And it doesn't matter if it's the first row or the second row. If all one row is zeros, then it's infinitely many solutions. Are we good? Okay? Now, that is the easiest way to solve one of these. However, State Course of Study says I have to teach you how to solve it using an inverse, because we do. So if A is a coefficient matrix and B is an answer matrix, coefficients, of course, are the numbers here. This would be the coefficient part. This would be the coefficient part, and this right here would be the answer part. Get it? So here's what happens. It would look like this. We know A times X equals B. Now, how do I get rid of A? You guys want to say divide, but we don't divide matrices. We have to get rid of it though, don't we? And typically when we undo something, think about what we just did, trig. To undo a trig function, we used its inverse, didn't we? So we're going to do the same thing here. We are going to apply the inverse. So what we end up happening is this. We have AX equals B, and what we do is we put A inverse here, and order does matter. A inverse here, and that's going to go away. So what you notice is that X is equal to A inverse times the solution, the answer matrix, doesn't it? I have to be careful about saying solution matrix. So now we can do this using our calculator as well. We just have to put stuff in the right way, okay? So now what is A going to be here? What is my coefficients matrix going to be? We're going to strip the coefficients off, the coefficient part. So what are my coefficients going to be? 2, negative 3. And then the next line would be? Now the answer matrix is just going to be a 2 by 1. Notice that was a 2 by 2. So what is my answer matrix going to be? Yep, negative 1, 3. So now AXB can be written as 2, negative 3, negative 3, 5 times X equals negative 1, 3. Okay? Now X is going to be A inverse B. Now we can find A inverse using our calculator. So all we're going to have to do is plug into our calculator. We're going to put our matrix in, find its inverse, and then multiply it. We're going to put our A in, we're going to put B in. So this is where I need you to go to your calculator. So let's go over. So as you can see, if you choose it, you do it using inverses or reduced row echelon form, which is what I would do. Now, let's talk about applications here. Applications. This is the big deal. It's not, can you punch a bunch of numbers in? What you need to be able to do is you need to be able to write the matrix, write the system of equations so that you can then transfer it into reduced row echelon form and solve it. That's the hard part of solving. So it says write equations using the information given. Use either reduced row echelon form or inverse matrices to solve and give your answer in context. Marquis has 22 coins that are nickels, dimes, and quarters. So we have nickels, dimes, and quarters, which means we have 3 different things, don't we? Which means we are going to have 3 equations with 3 unknowns. Do you know what our 3 unknowns are going to be? Nickels, dimes, and quarters. So our first equation is going to be, and he has 22 total. So if we take nickels plus dimes plus quarters, what should we get? 22. Then he says the value of the coins is $2.75. So what we can do here is we can say, how much are nickels worth? 0.05 cents. So 0.05 times nickels plus, how much are dimes worth then? So 0.10 times dimes plus quarters equals, how much are they all worth? $2.75. Not how many are there, how much are they worth? Remember, in coin problems, you usually have one that's the number of coins and one that's the value of the coins. Now, we need one more row. It says he has 3 fewer dimes than twice the number of quarters. So if we take twice the number of quarters, that should equal dimes what? 3 fewer dimes. See, you want to say minus, but he has 3 fewer dimes than twice the number of quarters. So if he has 3 less, then to get the same number on both sides, we would have to add 3, wouldn't we? Now, this guy needs to be turned into a form like the rest of them. So if I want to turn that into the form like the rest of them, I need to take my D and move it to the other side, don't I? Do you get it? So what do I need to do here? Yeah, I'm going to subtract D from both sides, and I'm going to end up with negative D plus 2Q equals 3. And now why am I putting it that way? Because look at the order everything else is going into. N, D, Q. Now, we need to set up our reduced row echelon form, don't we? I'm just going to go ahead and do reduced row echelon form because I know that's what y'all are going to do. So what is the first row in my reduced row echelon form going to look like? 1, 1, 1, and then what? 22. Okay? What's the next row going to look like? Yep, 2.75. And your calculator's not going to blink at the decimals, doesn't matter. Now the third row is the one that's always tricky for everybody. What is n? What's the coefficient in front of n in the third one? Is there an n? So what's the coefficient got to be if it's not there? 0. So 0, and then what? And order does matter here, so D comes next. So what's the coefficient in front of D? And what's the coefficient in front of Q? And then this is 3. So what I would like you to do is I would like you to take that reduced row echelon form and turn it into, we should expect to see 1, 0, 0 something, shouldn't we? 0, 1, 0, 0, 0, 1, and then I want you to solve this. Get it put into your equation, put into your matrix, and then do reduced row echelon form on it. If you need help, let me know. You should end up with whole numbers. No, if you're doing reduced row echelon form, which is the easiest, you just put it in one big matrix. You would do 3 rows by 4 columns, so it'd be a 3 by 4. Did everybody get that as your reduced row echelon form matrix? So now remember what it said. It said write the answer in terms of context. So what does the 7 stand for? Number of what? Guys, you have to be able to interpret these too. What was the first variable? No, the first variable was not 1. The first variable is what?
Nickels.
Stands for nickel. So this tells me I have how many what? I have 7 nickels, which means I have what? 9 dimes and
6 quarters.
okay.
Well, okay.
Okay. So the hard part really is just getting the equations written, isn't it? Which you can do that. Yeah.
After you get it in the matrix, what do you do?
Okay. Remember, it's in here. All right. It's now. You don't even have to do it. Remember, it's go to
Oh, okay.
second matrix. No, second matrix. Go over to math. And go down to your reduced. I don't need it. Just go down to this. Now, go get second matrix again. And ask you to do that on when you filled it. Okay. That's good. And everybody else good? This is not exactly hard, is it? Now, what if it asks you if something has an inverse? Can you put a matrix in and tell whether or not it has an inverse? Yeah. What is it going to say if it doesn't have an inverse? Let's look. What do we do if something doesn't have an inverse? Because a lot of times that's something you get asked. So let's enter this matrix and see if we... Let's enter this matrix. Does it have an inverse? So put this one in your calculator. 5, 2, -1. 4, 7, -3. 1, -5, 2. So you want to enter this in as A, and then you want to hit A and then hit the inverse button. I'm going to tell you right now, this does not have an inverse, and I want you to look at what it says if it does not have an inverse. If it has an inverse, it'll give it to you. If it doesn't, it's going to say something very specific. It's going to give you an error and say something. Does everybody have this one in? Here. Does that help? Okay. So everybody have this one entered in. Can I clear it off? Okay. If it does not have an inverse, and if it doesn't have an inverse, guess what that means? It means you can't solve it, can you? So if it has no inverse, it's going to say singular. As the error. Okay? That's how you know. All right, you ought to be able to solve any set of, find out if something has an inverse. Take the determinant of something. Do you remember when we made you do determinants? Do you remember Kramer's rule? When you had to do a 3x3 determinant? Kind of sucked, didn't it? You had to do all the... do y'all remember anything about matrices from last year?
We just plugged them in. Yeah, just plugged them in.
Oh, you weren't supposed to plug them in the calculator last year. You were supposed to do them by hand.
I mean, I'm
She
sure
taught
we
us to do
learned
it,
how.
just
I
can't
don't
remember.
know.
Okay.
She taught us to do it by hand.
If you did a 3x3 and you were finding the determinant, find the determinant of this guy. Remember, it's the long, these guys right here. It's the long, it's not a bracket, it's just the long piece. Let's say 1, 2, 3, 4, 5, 6, 7, 8, 9. Do you remember that you repeated the first 2 rows again? And then you did this way, multiplied this way, this way, this way, and added them. And then you multiplied the other way. This way, this way, this way. Added them. So we did plus, 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 plus. We got something here, and we got something here, and we took this guy and subtracted that guy from it, and that was the determinant. Yeah, your calculator says you don't have to do that anymore. So put 1, 2, 3, 4, 5, 6, 7, 8, 9 in your calculator. And we'll look. So if you look at do it using what? We have some ways to do translations. If we want to translate left or right, if we want to ordered pair matrix, of course, you know how to write an ordered pair matrix already, don't you? X sub 1, Y sub 1, X sub 2, Y sub 2, X sub 3, Y sub 3, and so on, right? We just keep putting ordered pairs straight up and down. This is called an ordered pair matrix. X, Y, X, Y, X, Y, X, Y. This is different than what we were just doing, okay? This is not a coefficients matrix. Now, to translate left and right, we are only changing the x's, aren't we? Does everybody agree with that? We're only changing the x's, which means we're only changing the top row.
Duffy?
Yes?
Hey, can you send Joanna and Pablo to the front, please?
Sure. Guys, we're only changing the top row. So if we're only changing the top row, that means our translation, we just put H's there in however many places we need, and then guess what goes in the Y for the Y's? Left, right is an X change, isn't it? Are we changing the Y's at all? Left and right, are we changing the Y coordinate of the ordered pairs? No. So guess what goes there? Zeros. And if we add those two matrices, then we get a new matrix. That is all where all the ordered pairs have been moved the same amount. So up, down should be pretty reasonable to understand. Instead of the H's going there, we're going to put what? Zeros for X's, and then we're going to put a number, whatever number we're moving left or right, into that spot, the Y spot. Now, if we are dilating by a factor of C, we are simply going to multiply everything through by C. So whatever the dilation factor is just goes out there. Okay? Now, reflection across the x-axis. If we are reflecting across the x-axis, guys, that is changing all the positive y's to negative y's, isn't it? Think about it. If we're going from the top here to the bottom, we're going across the x-axis. It's not changing the x value, it's only changing the y value, isn't it? So this is what our matrix looks like that we multiply by. 1, 0, 0, 1. Think about it. There's a 1 in the x spot. That means none of the x's change. And there's a negative 1 in the y spot, which means all the y's change to negatives, don't they? So now, I want you to think about it. If we're going across the y-axis, this time, if we're flipping from the y-axis to here, the y coordinate is not changing, is it? So that's a 0, 1. But the x coordinate, if we're going from the first quadrant to the second quadrant, the x coordinate is going from being positive to being what? Negative. So this becomes negative 1, 0. If we are going across the y-axis, or across the line y equals x, in other words, this would be a rotation around, wouldn't it? Across y equals x. Y'all understand when we talk about this, we're going from here down to here, aren't we? Yes? That means my xy becomes yx, doesn't it? X becomes a y becomes an x. For x to become a y, 0, 1. For a y to become an x, 1, 0. Does that make sense to everybody? The 1, the multiplier is in the y place now, and in the second line it's in the x place, which should be where the y line is. What would we do if we multiplied across the line y, or went across the line y equals negative x? What about y equals negative x? What would that matrix look like? Okay? Now, let's look at the next one. What if we're going across? Oh, I didn't want to do that. What if we're rotating about the origin? Origin rotation makes a positive x a negative x, doesn't it? And in the positive y a negative y. That means we're doing this. We're taking a positive x and turning it into a negative x. We're taking a positive y and turning it into a negative y. (90 degrees clockwise). 0, 1, negative 1, 0. All of these we're just multiplying. 90 degrees counterclockwise would make sense. If you think about it, this would become 0, negative 1, and this would become 1, 0 instead. So how do we actually do this in our calculator? Here's how you do it. First you need to write it. What is the reflection? If we're going across the y-axis, which matrix do we put here? We put the matrix that we're going to use first. To reflect across the y-axis, look up here. Reflect across the y-axis is which one? Yep. Negative 1, 0. 0, 1, right? Then we're going to put this guy right here. If there's just 1, we put 1 column. If there's 2, we put 2 points, we put 2 columns, and so on. So we're going to put the points in the next matrix. And we are going to be multiplying those. Okay? So now to do this, we just throw these in our calculator. And we literally multiply them. So we're going to go. Yep, negative 1, 0. 0, negative 1. So this is our new A. We're going to multiply it by B, which we already have in. And we should get a new matrix. What if we have more than 1 point? It just means our matrix B is going to be even bigger. We'll see that in the next one, okay? Everybody get negative 2, negative 3? All right, so how do we reflect triangle ABC across the x-axis? What's my what's my matrix going to be to reflect across the x-axis? Am I right? 1, 0, 0, negative 1? Will that take me across the x-axis? Now what goes in the next one is I have 3 points. I can do them individually or I can put them all in at once. Point 1, or point A, point B, and then point C, and guess what comes out? When I put this in my calculator, guess what comes out? So do that one. These aren't going to change, are they? These, however. So this would be point A prime, this would be B prime, and this would be C prime when you get done. Those would be the coordinates. Make sure you work through this on your calculator and you can get it. Did everybody get it? Okay, so what do I have to add to this matrix to translate it 4 spaces to the left? -4 to all of which ones? The x's or the y's? Good. So what we do is -4, -4, -4, -4. 0, 0, 0, 0. You can do this on your calculator or you can do it in your head. -1 minus 4 is -5. 3 minus 4 is -1. 4 minus 4 is 0. 6 minus 4 is 2. And we know that the y coordinates are not changing, are they? So you can use your calculator or you can not use your calculator. And that would be easier. So does everybody feel like you can do this now? Look at one more example, and then we'll go on to some other stuff. What transformation is happening here? Is anything happening to the y's? Okay. Is anything happening to the x's? Is the same thing happening to all the x's? Okay, so the x's are, what's happening to each one of the x's? Okay, so we're subtracting 4 from x's. So that means it's what? 4 spaces what? Yeah, 4 spaces left. Okay? All right. So you can tell sometimes what's happening, can't you? Are they changing positions? Are they just changing signs? You can tell. All right, so now, let's look at this. 2 units to the right, 3 units down. Now I can translate each one of those, or I can actually do this in my calculator. If I want to do 2 units to the right and 3 units down, what do I want to add to all of these? What do I want to add to all the x's? 2 units to the right would be the x's, wouldn't it? So these would be 2, 2, 2, 2, wouldn't it? 3 units down would be what? Yep, -3, -3, -3, -3. So if you want to very quickly put both of those in your calculator, let's figure out what that's going to be. Or you can do it in your head. I really don't care. -6 plus 2, -4, -2, 0, 1. And this would be A prime, B prime, C prime, D prime. And we could graph these. So -4, 1. -2, 2. So there's A prime to B prime. 0, 0. And then -1, -2. And look at that. We have now translated that puppy 2 to the right, 3 down. Rather than having to count spaces for every single one of them, we just do it all at once, and then we can plot them, can't we? All right, so example 2, multiple choice question. What matrix would you use to translate the vertices of a pentagon? 3 units left, 2 units up. Pentagon has how many sides? 5, so it has 5 coordinates, doesn't it? So 3 left and 2 units up. Is it A, B, C, or D? Yeah. Ansley says A. Is she correct? Yeah. These are my X's, right? That's 3 to the left, that's 2 up, so A is correct. And there are 5 of them. Now actually do the translation. So that means I have to do 0, 5, -1, -1, -5, 0, 1, 3, and 4, 0, don't I? And what am I adding to that? 3 to the left. 2 up. And I should be able to get a It does, doesn't it? -1, -1. Well, they might not be in the correct order. Unless I have some sort of mistake in here, which I might. There might be a mistake in one of the answers. This should just be what? 7? 5 plus 2? Okay. I think there was a mistake on it. Everything else fits, doesn't it? So what's the answer? B. Okay, we're just going to find the new one and match up to the points, don't we? So do I have to use my calculator on all these? Not necessarily. All right. How do we dilate? I have to do my coordinate matrix first, don't I? And what did we say dilation is? We just literally multiply out front. Yeah. So how do we do this on my calculator? You need to put this in as matrix A. And we're going to do, so enter this as matrix A. And then we're going to do 1.5 times, and then we're going to do A. And it should give us a new 4x4 matrix. Make sure you can get them. I think we'll skip those two examples. I think we did enough of those earlier. You just need to know how to set them up and put them in your calculator, don't you? Which one to pick. Make sure you get the right matrix answer. Are we good? Okay. Last but not least, let's look at finding the area of a triangle. We can use the matrix to find and determinants to find the area of a triangle. The area of a triangle that has 3 different vertices. Notice what we do. We put the vertices in this way this time. We find the determinant of it, and we take half of that. Half the determinant. Now, why does it say plus or minus here? Can we ever have an area that's negative? No. Area is positive by nature, isn't it? We have a positive area. Now, however, the determinant can end up as negative. So we multiply by a half, but we know the answer is always what? Yeah. Okay? So whether or not we use plus 1/2 or minus 1/2 really just depends on what the determinant is. Okay? Or you can skip that, just multiply by half, and just know that your answer is always going to be what? Positive. Okay? So we're going to try an example of this. And why did we put ones down there? It was just to make it nice and square, because we can only do the determinant of a square matrix. Everybody want to try? Let's try one here. We're given 3 triangles. So the first thing we need to do is find our coordinates, don't we? So what is the coordinate of this guy? Okay. And then we have -5, -6 over here, and +6, -6 here. So I'm going to do a half times the determinant of -5, 7, 1. And no, it does not matter which order you put these in. -5, -6, 1, 6, -6, 1. So I'm going to put that in my calculator. I'm going to put this matrix in. I'm going to put this in as A. And I'm going to do DET, matrix A. And then I'm going to take whatever that answer is, and I'm going to do 1/2. You can put the 1/2 in front. 1/2 times the determinant of A. And the cool thing is we can actually check this, because this is the right triangle. Because we know the area of a triangle is 1/2 based on height, doesn't it? So the base is from -6 to +6, that's 12. And from -6 to +7 would be 13. So 1/2 12 times 13. And now put them in your calculator and see. That way you don't have to. See, if it's rotated, you can't do that, can you? Yes?
Hey, Sarah Red. I'm sorry, never mind.
Okay, thank you. All right, did everybody get 78? Yes, no? We're having trouble, we're not having trouble? matrix in first.
I'm sorry, Miss Duffy. I do need your reference
Okay.
cafeteria.
Cafeteria, okay. No problem. Cafeteria. So we're gonna hit second matrix, we're gonna edit A. We're gonna make it a 3 by 3, aren't we? And we're gonna do -5, 7, 1, -5, -6, 1, and 6, -6, 1. Put out of that, we're gonna hit 0.5 times second matrix, go over to math, determinant, second matrix A. Oh, 71.5? I don't know what I did wrong there, but yeah, 71.5, excuse me. So does everybody feel like they can find a determinant? Determine whether something has an inverse. Use inverses to solve, use reduced row echelon form to solve. Set up an equation and solve it. That's all there is to this, guys. 99% of this is just doing stuff on your calculator, okay? Now, this is just a very simple, very short section. What that means is notice that your homework says what on it? It says test review. You're going to have a short test, because I'm being really nice to you. You're going to have a short test next week on matrices, okay? But what do you need to be studying for between now and Wednesday? Big test, last big one, okay? All right. So you know what to do. Wednesday you have a test on trig. Friday we will go over this. This homework is due Friday, okay? Friday we will go over this, and we will talk about complex numbers. All right, that's what the last thing we'll cover is complex numbers. Okay.
Are we gonna have a test on complex?
Complex numbers will be on your exam. You'll have short quizzes, like daily quizzes. You'll have those. But if you're not taking the exam, you won't have a big test on complex numbers. No. Complex and polar.
There is a test on this, right?
Oh, yeah.
Tuesday?
Yes.
Okay.
There is a test on which? Yes, next Tuesday will be a test on that. Yes. Be sure you know how to do all the stuff on this slide.
Yeah.
If you put in A, B, C, D, E, and F, I just go ahead and put all those in your calculator at once. And then just do 2A plus 3B using your matrix operations. This means determinant, right? The rest of it's just multiplying. Just need to know that you know how to do matrices on your calculator, because that's my job.